Hello, I'm Alda Jaffa, a graduate student in Master of Telecommunication Engineering. I came from Open University of Catalonia in Barcelona, Spain. I worked with Pere Tusset, an assistant professor, and Xavier Villalosana, an associate professor of the same university. The topic we are going to talk about today is a wireless PID control of a thermal process using ultra-low-cost, long-wave infrared camera. These type of cameras are becoming a key tool in the industry applications about its ability to sense temperature without the physical contact. Nowadays, these type of cameras can be used for predictive maintenance of motors and other equipments in the industry. What we are going to show is how a low-cost long infrared camera, FLIR-Lepton in this case, can be used to control the intensity of the temperature of an incandescent light bulb by using a distributed PID controller. The system is composed by three main subsystems. The first one, it is the sensor actuation, the data processing, which is the cloud, and the real-time actuation. The sensor acquisition, it is composed by a microcontroller, a Cortex M4, a Wi-Fi interface, which is the CC3100, and the camera, the FLIR-Lepton. The camera acquires images from the light bulb, in this case. This camera, it is self-calibrated. That means that every 1 minute it self-calibrates to give good temperature values. It takes the images from the light bulb and sends these images to the cloud. In the cloud, it is done the data processing. That means that the image, it is consolidated, are calculated the temperatures for each pixel, and it is defined the peak value of the temperature, the maximum one. We have set a set point by the user. In this case, it is 65 degrees Celsius, and with the maximum temperature of the image taken from the camera, it is performed a PID loop that returns a PWM value that is sent to the real-time actuator. In the real-time actuator, which is composed again by the microcontroller and the Wi-Fi interface, and also with a dimmer, the PWM value are sent from the cloud to the real-time actuator, and it is performed the power control of the incandescent bulb via I2C communication. We can make an example by setting the temperature value that we want that this bulb have by 70 degrees Celsius. As we can see, the current value, it is higher than the target value that we want. So the PID control, the PWM, we set up to the maximum, to 100, that can power up the light bulb, and then it will compensate when the target value gets equal to the current value. So this bulb achieved to the temperature we want. The main idea of this project, it is the cyber physical systems for the students, because we are an open university, an online university, and we want that the students can see how the cyber physical system works by combining the communications, the computation, and also the embedded systems all in one, and they can remotely run from their homes and make different simulations to see how these type of systems work.